So in this video, we're going to take a look at some problems that I've pulled from the beginning of a calculus textbook. And if you notice, they've given us these 6 expressions here, and the directions say to convert each expression into exponential form. So what you're going to realize pretty early on in calculus, as soon as you start taking derivatives, is that you absolutely positively are going to love situations when you're faced with just x raised to powers. You're not going to like roots quite as much. You're not going to like x's in denominators quite as much. So what we're going to utilize on this screen is going to be a set of exponent properties, and we're going to try to manipulate these expressions until we end up getting the expression into a form that is essentially easy to take a derivative with and easy to do an integral with. Now you're not going to know quite what those terms are until later, but the algebra we should be able to understand right now. So if you have the nth root of x to the m power, what you can do is you can rewrite this as x to the m over n. Basically, the index of the root becomes the denominator of the exponent. The other property that we're going to use here would be if you have 1 over x to the n. What you're allowed to do is you're allowed to move that x across the fraction bar into the numerator as long as you change the sign on its exponent from a positive to a negative. So these are properties that you've seen in other math courses. What we want to do here, and we'll take a look at the evens, so we'll look at number 8, 10, and 12. What we want to do with number 8 is we want to rewrite it without a root. We want to rewrite it so that it's just x raised to a power. And so it's just a direct application of this property here. We're going to have x to the second, but then it's not going to be underneath the cube root anymore. The index of the root is going to become the denominator of the exponent. And that's it. This is now x to a power. We like situations like this. In number 9, and this is kind of goofy because in previous, actually we're skipping number 9, meant to go to number 10. In number 10, which is very similar to number 9, you have an expression that in previous math classes you probably would have said is simplified. In previous math courses, you probably say you want to rewrite something without negative exponents if you want to simplify it. Well, here, what we want to do is we want to rewrite it so that it's just a number and then x to a power. We don't want a fraction like this. So all we really have to do is move that x across the fraction bar, change the sign on its exponent, and the 4 just stays put. So we end up with 4 times x to a power, and this is what we would call exponential form. Not necessarily a simplified form, but it will be a form that will be beneficial for us later on in the year at different times. And then the last one here we'll do, the last even one, is number 12. This one is going to kind of involve both of the properties that we used in 8 and 10 for the same expression here. And what I'm going to do is initially get rid of the root. So this is a square root. Right, so I have this coefficient of 2 that's there, but then instead of 2 times the square root of x to the third, I'm going to write x to the third, but then I'm going to re-represent the square root as an exponent by putting the exponent over 2. So again, the index of the root, 2 in this case, becomes the denominator of the exponent. Now this is not a number times x to a power yet. What I'm going to do is I'm going to copy down the constant part of this, the coefficient of 3/2, right, the 3 over 2, but then I'm going to move the x across the fraction bar into the numerator by changing the sign on the exponent. So these are things that involve properties you've used before, but we're using them in a slightly different way. It's going to be beneficial for us to be able to manipulate expressions so that they're just x raised to powers later on in the year.